Taming the duck with type hints, and it's an introduction to static typing or type hints in Python. It's an introduction, so I'm going to go through things very quickly. What I'm really hoping is that if you've heard of it, but you haven't used it before, that this might give you some motivation to use it. So I'm going to do another one of these very shallow but hopefully broad talks. First, the context. Well, Python, it uses a typing system that I'm sure you're very familiar with called duck typing, which I'll get into a bit later because I want to contrast that with static typing. And the nice thing about it is it allows programmers to be quick and to very quickly develop programs without worrying about these pesky types. And again, we need to remember that Python was used in the education system early on in the US because it is a simple, elegant language. But the issue is that we don't have to think about types, but types are still there. And if we don't pass the correct types to a function, then we will have a problem. We will have an exception. So, you've got the trade-off. You're extremely productive and fast, but errors can still be there. So what this talk is looking at is where we get a helper to help us with finding those errors early on, which is the type hints. So in this talk, what we're going to be looking at is the whole different kind of typing, duck or otherwise, and I'm hoping that it answers the question for you, could it actually help you? Because I'm not going to say that everyone should be using type hints. That's silly. People have different ways. They have different areas that they're working in. But I'm hoping that you can make that decision a bit better. We're also going to look at some of the Python syntax to create these type hints, because I want to show you that it is quite a simple process. And also there's the questions of if you've already have a code base, how do you apply it? Do you have to apply all or a bit at a time? And the last point is what I started with, which is, but most of all, I'm hoping that you'll want to try it. Just have a look, see if it suits your style. So it's a bit of a taster of type hints. Okay, just a bit of background about myself. Why am I interested in type hints? Well, it's mainly because I've been working with statically typed languages for over 30 years. And as a kind of professional programmer, I want my tools, so my whole environment, my compilers, my editors, all that, I want them to help me to create code, to be able to understand code, so that's more kind of the editor and tools, but also to make more correct code. Debugging is much harder than if you write it correctly in the first place. So, and with C, C++, I'm used to a compiler that gives me these checks so that I can write more correct code. But I've started using the type hints, so I haven't used them a heck of a lot, but because I'm not focusing totally on Python, but I do use it for tooling and test. And I've found that I am getting the same sort of benefits that I get from my C++ compiler when I'm using the type hints. Just an aside, about 5 years ago, I actually went to Go language for a while, and it was all because I was frustrated that when I had large code bases in Python, I couldn't find the mistakes without testing or shipping, even worse. So I liked Go, but I still really liked Python better. But I did find things like interfaces and that we'll be looking at a bit later that were very useful. So that's why I'm interested in this. Okay, so let's start talking about types. And types of types is kind of neat. It sounds very meta. But as I said at the very beginning, Python has types. So like, integers, bools, floats, all of those types that we're used to, and also some of the types of why I found Python so interesting when I first came to it, which were the collection types, the tuples and dictionaries. And they also have some special ones like callable and things like that that are quite interesting. So Python has lots of types. In fact, every object or variable that you create in Python has a type and a value and an ID and some other things, but every object is an object of a certain type. And the type that the object is, that defines what operations are valid on that, the value of the type, what it can do. I've got some examples that will make more sense in a second. So, and when we try to use an invalid operation on an object, we get an exception. So this is the case where you have a function that's doing something, somebody's passed an object in, which is of the wrong type, you try to use it, you get an exception. Now, something I find that's really good about Python is this fail fast idea. So it doesn't try to coerce types behind the scenes for you and like, just carry on. Instead, it tries to do the operation, and if it can't do it, an exception's raised. And in fact, there's been a lot of work on error messages recently that has made these error messages that you get in the exception make a lot more sense. So I actually like that. By the way, I'm going to be using names in this talk not particularly precisely, and that's because I just want to get the idea across. So, but one name I'm using a lot of is type hints, and I'm sticking with that because I really like the idea that it's saying this is a hint. It's not part of the language, it's not constraining the language, it's a hint to other tools. So instead of things like type annotations or statically typed, that's why we call it type hints. Okay. Right, so I'm going to look, wow, that's really high, isn't it? I'm going to just look at some of the terms that we talk about when we say Python is a dynamically typed, duck-typed language. So in the way that I'm looking at dynamic typing here is just the fact that if you have a variable, I'm going to call it a variable instead of an object. If you have a variable of a particular name, like factor, it now has a type. So when it's first assigned, Python knows this is a string, and if I actually ran this, the type factor would actually say, yeah, it's a string. But we can actually change that type. So when we say factor equal 2.7, as well as changing the value, it changes the type for that. So that's the dynamic typing that I'm talking about here. Now, again, it makes it easier to program in Python, especially for beginners, because there's less rules for them to learn. It just kind of works. So there's definitely a benefit there. But it also, as your program grows, it actually makes it harder to reason and discuss the code. Because what is factor? Well, factor at the top is one thing, and factor later is something different. So it has a bit of a code smell that is valid in the language, but isn't necessarily the best coding to use. Okay, the good one, the interesting one, duck typing. Now, I'm sure most of you are aware of this. You've been using Python. But the idea behind it is it comes from this saying that if it walks like a duck and quacks like a duck, then it must be a duck. So this is kind of like a good enough principle. If it's close enough to a duck, the stuff I want, like in this case it would be walking and quacking, as long as it can do those two things, I'm going to call it a duck for my purposes. So that's the idea behind duck typing. And Python uses that by assuming. So it's an optimist. It's saying, well, hey, I've got a function, you passed me a parameter, and you know that it should be a duck, so I'm going to assume it's a duck, and I'll ask it to quack for me. And if we actually ask it to quack and it doesn't know how to quack, taking this one a bit far, unfortunately, but then we will get an exception. So if the type isn't compatible, isn't the right type, we will get an exception. So another thing I'll be saying a couple times during this talk is that all Python code uses and will continue to use duck and dynamic typing. Nobody's suggesting we actually change that. So when you take a look at this code, you can see that there's a function scale down, which takes a value and a factor. So it's an idea of scaling down a number and returning that. And at the very beginning, we pass it the float value and the float or integer factor. And the scale value, it runs fine. But if we then change the factor to actually be of a different type, where it's now string, then when we run it, we get this exception raised. So, and that is Python just giving it a go and finding that it didn't work and then informing the user, failing fast. Okay, type hints. 10 minutes in, we're starting to talk about type hints. So what's happened here is on the top function, I have added hints to tell who, I'll say in a second, but it's hints for what the type of the value and factor is, and also what it returns. So the hint is just a type after a colon for the arguments, and an arrow and a type for the return. But everything else looks exactly the same. You still have the colon at the end of the float on the right to say that we are defining a function, and the body's below. Nothing else has changed there. But the interesting bit is if we now run this in Python, nothing changes. And that's what's important, because a lot of people, when type hints first were talked about in 2015, they were totally against them, because they're saying this is changing a language I know and love. But it didn't change the language. Why have we done it? Well, we've done it because we can now use type checkers. And so this slide is talking about a particular type checker called MyPy. And there's quite a few out there. And on the top line, I'm saying that there's PyType, PyWrite, PyCharm, and more. I'm just using MyPy because it's open source, easy to see. It was one of the first ones along with PyCharm. And so, yeah, through this talk, we're just talking about MyPy. So running this type checker is as simple as invoking MyPy with the name of your top-level file. And it will actually look at all files that it imports and do an analysis using the type hints to figure out what should be correct. So when that happens, we actually get two errors. I'm going to look at the second one first. So the second error is exactly where Python complained, where it was saying that the second argument, I can't divide that because dividing a float by a string isn't supported. But the first error is kind of interesting. So this one is looking at the dynamic types. And as I said before, dynamic types are okay in the language, but it does and can make your code a bit harder to understand. So instead of dynamic types, why not have two different variables? And then the names can actually make more sense. So it's actually picked up that the type of that variable had changed. And we're going to look at how it does that in a second. Okay, so static typing with dynamic typing. And duck, but we're going to get more to that in a minute. But the static typing comes by way of type hints, as we saw, and that we use different type checking tools to check that. The other nice thing is that the IDEs or editors are using that same information now. PyCharm started it from my reading, but now, like my editor Emacs, it understands it as well. So it's actually checking, doing those MyPy checks as I type. And I just, again, this is the last time I'll say it, but the goal of type hints, at least in the C Python implementation, is not to use them for the language, but it's to be used by the separate tools. And that was said in PEP 526. Okay, so now we're going to look at, we looked at using type hints for function arguments. Now let's take a look at using type hints for variables. And the top example, I'm having trouble reading my screen here because of the lights, but the top example is where we have two variables, color and files. And MyPy infers the types when it sees them, as I kind of mentioned before. And in this little piece of code, I've changed the type on it. So then when I run MyPy on it, so there's no functions here at all, but when I run MyPy on it, it's telling me again that these types have changed. So it gives it to me for free. But that inferring of types, it does have some problems. And an example of that is when we want to use none to carry error information back from a function, say. So we start out and we say, okay, this variable is none, but normally if we didn't have an error, it's going to be a list of strings. So that's what my files one was there. So on the second code fragment, we're using a module that is in Python called typing, and we're using something out of that called optional. So I've just thrown this in now. I'll explain this in more detail further on. But then we're making the type of file list. We're giving the hint that it is a list of strings, or it could be none. And that's exactly what optional means. So when I assign none to it, MyPy at the bottom, it was fine with that. If I just said it was a list of strings, it would have given me an error on that. So now I can assign a new list of strings to it. I can add to that. Bit of a mistake in my code. I meant to say file2, but hey, we can live. Okay, now this is something that I really like, where with Python, as we all know, we have a convention for constants, which is just the uppercase snake case for constants. And that's worked reasonably well, but if somebody actually assigns to the constant later, there's no implications of that. So it's easy for us to have an error in it. So again, from the typing module, we have this idea of a final, which means it can be assigned once, but it can't be changed. So with the type, or with the constants, the default scale factor and so on, I've hinted that this can't be changed, it's final, and it has a type of float. And similarly with the string, I'm violating that in the next, lines 8 and 9, so I'm violating that, and when I run MyPy over it, it's telling me that the problem here was not that you had a change of type, it was that you assigned to it at all. I really like this. I'm always assuming that, I'll set up something and I'll say, hey, this is a constant, and then somebody will change it, and it's hard to find. So it's a small thing, but I really like it. Okay. So type checkers understand a lot of types. So we're now up to a stage where a lot of PEPs have come through the system since Python 3.5, and there's been a lot of extra type machinery added so that we can easily put in hints that really reflect our code. So we've got all the simple types, like integers, floats, and so on. But we also have the collections. And you can see the syntax there, where we use a square bracket to say what the types are for that collection. So tuple, it can have each of its indices. Each of its things in the tuple can be different types, so I've said that as T1, T2, and so on, where with a list we have a single type and a set. And a dictionary, we have a type for the key and a type for the value, and they can be different. And of course, any of those types can be inside a collection, so you can start to have types inside types. But it reflects the code we write, and that's the key thing. If the machinery wasn't up to the code that we write, nobody would use it. Okay, so I just did a reasonably complex one with that list, which has a tuple, and so on. And the other one, of course, is classes. Classes are types as well, so we can use a class from the standard library, we can use our own, and we can type hint that we expect an object of this particular class. Okay, so some really bad examples. They're just little code snippets of just showing how we can use the type hints with the count list, where we say that we will pass in a list of integers and return an integer. Same idea for find keys, but we're using a dictionary. So that syntax it's pretty small. There's not a lot of noise. Originally, there was type hints in documentation, all that stuff. It was so verbose for a small code fragment like this. Your type information would be larger than the fragment. So this is quite succinct. With the line 8, I'm actually using something called a type alias. And the idea here is to make things readable. So we actually, bday is actually a new type, which means the tuple type that you see there. And I'll show that in a slide or two. So we have our add birthdays that take a list of that tuple type and a single tuple type, or sorry, a single bday one to add a birthday to that list. Okay. Again, I'm going through stuff really quickly because I'm assuming that a lot of people are used to some of this, and I want to get to some interesting ones. But I put this slide early because I was afraid that I would go too slow and I would run out of time, so I still have 7 minutes, so it's not too bad. But so here's the question that I wanted to answer at the beginning, and I want, have I convinced you that these are easy to use but helpful? So again, this is the third time I'm going to mention that Python remains a dynamic duck type language, and you lose nothing when you go to type hints, though there are some cons, which is coming up. So the pros, what do you get? Well, it means that you can use a type checker to help you. So in this case, I was using MyPy, but it's true of a whole bunch of other ones. And one of the interesting things is that there is the definition of the full standard library. When you download MyPy, you get this thing called the type shed with the current instance of it, and it has all of the stubs for the standard library. So all of your use will be checked. All of your code will be checked when you use the standard library. I mentioned before that IDEs and editors are using these hints to provide better tooling. I'm really liking that. Better documentation as well, where you're actually saying what your intent is with the code, that you're expecting that a variable of this type will be passed to you. The downside is that you have to take the time to, one, not reuse variables for different purposes. Think about the functions a bit more and be explicit about the types. Add the type hints in. And the other one is run a type checker against it, because if you don't run a type checker against it, that was a bit of a waste of time. And if you have a large code base, that can be a bit more difficult to add type hints, because when you start adding type hints, you will start getting errors, and it can be a bit more difficult. And again, everybody doesn't have to use type hints because it just depends on if it goes with your style. But trying it, I think that's something that we can do. Okay, so some more interesting machinery is I've shown optional from the typing module. We also have some other special types like any. And any is the default type. When MyPy looks at your code to check it, it defaults to any for all of the arguments, all of the variables. And what any means is it basically just means anything can happen, so there's no use to check it, because anything can happen. So that's the default. Any string is kind of interesting because we often have interfaces that take either a string or bytes. Any string says it's just a type that can be either of those, but it makes sure you don't mix them. So if you want bytes to be passed for both parameters, then this will do it for you, or string. The other interesting one I really like is the union. So the union is a way of saying, in this function, I will take floats or I will take strings. Now, of course, if you do that, you then have to make sure that you check it correctly in your code, because you could get one or the other. You can't assume that it's going to be a float. But that's where we have things like isInstance and isSubclass, where we can do that check. Same thing with the optional. We'd have to check to see if none was passed in. But then we have the if this is none. So we've got a way to do that. The code here, you can just see I've got union showing there, and that's actually the old style of union. Too difficult, don't want to have to do that. But you can see where we've just had a union of a string int or float, and we're using the isInstance in the code to make sure we don't call a function on something that the type doesn't support. On the take various, the second one, now we actually have, I think this came in 3.10, we can use the OR bar in type hints to let us define union type hints. And that is used a lot. Okay, I'm running a bit long. One other thing I just want to say, because it's so interesting, is I want to describe something called a protocol. And what this is duck typing. It's actually called structural typing in this case, but it allows us to say that this function, it takes not a particular type, but it takes an object that has quack. So what we do is we create on line 3 a protocol called supports quack in this case, and see the syntax where we just define the signature of a function, but then we use ellipsis, ... And that means we don't care about the body, we're only talking about the function signature. And then if we try to run this, we get an error because sorry, this isn't running, this is MyPy, this is the whole point. When we try to check it, we get an error immediately, which is saying that, hey, this one doesn't support quack. If we try it with a duck object that does support quack, then MyPy is totally fine. So this is where we're starting to go full circle, where we can still have duck typing, but we can also have checking as well. There is this idea of gradual type hinting, and it's because we've got millions of lines of Python code. So, we can just start putting typing on just a couple functions and just a couple files, and we can still check things. And I've got some hints at the bottom there, where with MyPy, the first one is that we can use an option called ignore missing imports, which allows us to say, don't worry about anything that I bring in. Sorry, I've got to wrap up. Work on type hints has been very fast and furious. 30 PEPs in 8 years. That's ridiculous, but that's because getting type machinery is hard. I've got some references here. The one I just want to point out is go to the mypy.org website, and it has, is it mypy.org? Anyways, the mypy website, it actually has a really good tutorial on everything to do with these types. Thank you very much, and don't forget to run the type checker.
Thank you, Brian. Unfortunately, we won't have time to take questions, but here's the mug.
Thanks very much. This is why we do it.
We'll be now heading on for a break, and then we'll be having lightning talks in Hall C at 3:50. Thank you, everyone.